You want to start with that?
Alright, so tell me what you see through these glasses. Different colors, right? Alright, so basically, if you look at the top one, you have yellow, green, and blue. And so combined together, they make the top light color. So basically, what these glasses are doing is they're separating out the codes of each of these lights. Now, look at the bottom one. That light is the entire spectrum. So basically, if you see the gaps between the lights, so there's yellow, green, the gap, and then blue. So what the light is doing is it's only emitting those three colors. So this is the bottom light is emitting what we call black body radiation, which is the entire spectrum. But certain gases, however, only emit certain spectrums. So this is simple. So this effect is caused by these glasses, which are called diffraction glasses. So what we do with this, the practical scientific application to this, is that this effect works in both ways. In other words, it emits these spectrums, but it can also absorb these spectrums. In the sun, if we looked at the sun through these, which you shouldn't do with spectrums, but if you did, you would see these colors would not be the ones showing. They would be the ones that are missing, because the sun has certain gases around it, and these gases will be absorbing this light. So using that effect, we can tell what the sun is made of, what gases the sun is made of. So this is very useful for very distant stars that we can't possibly travel to. So, yeah.
You get a question? Did you get it? Huh? Did you get it? Do you have any questions? No? You know why? Now do you know why? Got it?
Oh, you can take those with you.
Oh, do you want me to explain?
Yeah.
Okay. Okay, sorry. Okay, so if you look through the diffraction lenses, you will see these three will have several solid bars of color, right? And then the bottom one will have like the entire rainbow of color. This is because these three are specific gases. This one is, I believe, mercury, hydrogen, and neon.
What's the first one?
Mercury.
Oh, mercury.
Yes. So each gas would have several levels of light, like a fingerprint. So say neon is made up of a lot of red, some orange, and some yellow. And so based off of what colors the fingerprint emits, it will produce, it will consolidate into a color. So like a lot of red, a lot of orange, and a lot of yellow would make a very strong orange color. And for mercury, you get a strong yellow, green, and blue band, and then they combine to form this light blue band. And the bottom one is a normal light bulb made out of metal, so it produces a lot of energy in all levels, so it produces like the entire rainbow of colors. And for a practical application of this would be if you look at stars really far away. So if you look through some lenses and then you see like several bars of colors, and then you see what colors are there and what colors aren't there, you can find out what element that star is made of or is like around that star. So yeah.
So since the color with higher energy is closer to the middle, I'm thinking about the position, like why, like red is on the left.
Oh, that's because the colors of the rainbow have different wavelengths. I think red is around 400 nanometers. Red's on the higher end. Sorry, red. Okay, so like red is like 750 to 800, and then purple is 400, I think, and then everything else is in between. So these lenses will diffract the colors different distances. So like red would be say here, and then it'll slowly diffract over to purple.
That's not related to the energy.
Yeah, like that's just why. That's why
how
you
the visible spectrum has different. Yeah. So you know how prisms work, right? glass prism, how you can have light in and rainbows come out. This is basically a miniature prism. That's basically how it works. But except the prism separates light based on the velocity through the medium, through, say, a glass. This is separates the light based on the wavelength. So, yeah.
What is the material?
It is just
I think it's just plastic.
But
With
these have
a lot of over 15,000 tiny slits. Which, yeah.
So they cost, if you want to know how these work.
There's like a little change. Yeah. So actual slices, like I guess.
Yeah, the light travels through this waves, and there's interference. They how constructive and destructive light. Yeah, you only see it when it's constructively interfering. But yeah.
Yeah, you can take this.
Yeah.
Yeah, I will. Thank you. Thank you.